Good morning, students. In this video, I will be discussing about the basic Wireshark filters. So this is the live traffic I have captured, where there are more than 1483 packets have been captured. Okay. So first, let us see how to filter the traffic based on a particular protocol. So if you want to filter only the TCP packets, so this is the filtering bar. You can see, just you can type there TCP, and you can see the color of the filtering bar has been changed into green color. That indicates that the filter command what you have typed is correct. So if you type the wrong command like TCP something, so the color will not be in the green. Okay, that is just an indication to know for you that the filter what you have typed is correct or not. Okay. Now let us see how to filter the traffic that contains only the TCP packets. Just you can type TCP and then click enter, or you can see the blue arrow mark, you can click on it. Now you can see all the TCP protocols or the traffic has been filtered. So if you want UDP, you can just type UDP and then click enter. Only the UDP protocols traffic has been filtered. Similarly, if you want ARP, just you type ARP and then click enter. You can see the traffic that contains only the ARP protocols have been filtered. So in this way, whichever the traffic of a particular protocol you want, you can just type that and you can get it filtered. And it is possible to give multiple protocols at the same time. For example, TCP as well as and UDP. Both we can filter at a time, but that is not possible because traffic will contain either TCP packets or UDP packets. If you click enter also, there will be no traffic at all. Or you can go for or TCP or UDP. Means the traffic may contain either TCP or it may contain UDP. Then if you click enter, you can see all the packets that contains TCP or UDP, or you can give ARP. As per your requirement, you can just type any number of protocols on the filter bar and then click enter. Then this traffic will contain three different types of protocols, that is TCP, UDP, and ARP. Okay. So in this way, you can just filter the complete traffic based upon the type of protocol that you want to use. So think that you want to avoid some traffic from the entire traffic. For example, I don't want the ARP traffic in the overall traffic, or I don't want ARP packets in the traffic. Then what you can see, you can just give not ARP. And among these complete traffic, that is what we have like 1483 packets, it will just remove all the packets that are having ARP protocols. Just you click it. So not ARP. 1 second. Click enter. So that is filter. Now you can see the count of the packets is only 1483. So some packets are filtered. So displayed is only 1476 among this. Here you can see the count. Total packets are 1483. but displayed is 1476. Means I have just removed the ARP packets from the overall traffic. In the same way, you can remove UDP. I don't want UDP. Just you click and then click enter. So UDP packets are removed. You can see the count here. Selected packets is only 122 or UDP. So displayed is 1322 out of 1400 plus. So in this way, you can just filter the packets which you are not required. And here also you can give multiple filters like I don't want means not. You can give in the flower bracket. I don't want TCP packets or I don't want UDP packets as well as I don't want ARP packets. So these three packets I don't want. Just close the flower bracket. One second. So if I typed anywhere wrong, then automatically this color will not change. It should be in green color. Okay. I think it should be. It should be open bracket and a close bracket. So now what I'm trying to write here, I want to display only the traffic that doesn't contain, means not, it should not contain either TCP packets or UDP packets or ARP packets. So just click enter. Now you can see these are the only 4 packets among the traffic that eliminates all these 3. Means these are all the traffic that contains ICMP protocols. So in this way, you can just filter the whole traffic with the help of protocols. Okay. Now, we will try to filter the packets based upon the port numbers. So for example, I will just filter all the TCP packets, TCP. So I will just choose one of the TCP packet like packet number 122. Here you can see. Down if you see, in the upcoming videos, I will explain about all these uh, packet details in depth. Here you can see TCP, Transmission Control Protocol. And here you can see the source port is 1065. So I just wanted to filter all the TCP packets with port number 1065. So here I am not specifying either the source port or the destination port. I am just specifying the TCP port number should be 1065. Then what you can write here, you can just write TCP dot port. I am not specifying whether it is a source port or destination port. Just a general port. It may be in any of the case. So TCP dot port double equal to, I will just write 1065. Please keep in mind, again, I'm telling, I am not mentioning whether it is a source port number or it is a destination port number. It may be anywhere, but I need to filter all the TCP ports with port number 1065. Just click enter. So these are all the packets that are having the port number 1065. It may be source or it may be destination. If you want, you can check it. You click here. Here, see, the source port number is 1065. Here, 1065. So all are 1065. Here, see, here source port is something different, but destination port is 1065. So if you want to filter specifically the source port with 1065 number, then what you can do, you can just update it as TCP dot SRC, means source, PORT, source port, double equal. This will filter all the packets that are having the source port number 1065. Okay, just click enter. You can see there are 5 packets which are having the source port number 1065. So if you want a destination port number, I think we have one. You can just update it. TCP dot BST port double equal to 1065. Now you can see, yeah, there are again 6 packets which are having the destination port with 1065. If you want, you can check it. See here, the destination port is 1065. Destination port is 1065. So all are having the destination ports 1065. So in this way, you can filter all the packets with the help of port numbers. So even it is possible to filter the packets based upon the number, frame number. For example, I want to display only the packet of frame number 6 to 8. Just you can write here IP, or you can write it as frame dot number double equal to which number I want. For example, 630 I want. Just you write the frame number, then click enter. You can directly navigate to that particular frame number. So 630. So in this way, you can filter based upon the frame number. Now, if you want to filter based upon the address, means here you can see source address, destination address. So based upon the node or source address or destination address, you can filter the packets. So for example, if I write IP.addr, I am not mentioning whether it is a source IP address or destination IP address, a general address. So IP.addr double equal to, if I write to any of the address like 192.168.56.101. So now what I'm trying to do, I'm just filtering all the packets that are having the conversation or the IP address 192.168.56.101, whether it may be a source IP address or it may be a destination IP address. Are having the IP address that matches with it may be either source or it may be a destination. Okay. So specifically, if you want to display all the packets that are having the source IP address is this number 192.168.56.101. It should be a source IP address. Then what you can do, you can just update it as IP.src. Okay. No need to write address there. IP.src means I am just fetching the IP address of the source node with this number. Just click enter, then you can see totally 624 packets have been displayed. You can see here the source number is having 192.168.56.101, all the source numbers. Only the just to type it as IP.tst, then click enter. Now you can see the destination node means this one, fourth column 192.168.56.101. All are having the destination nodes that are matching with the given IP address. So in this way, you can just filter all the IP addresses, whether it may be a source or destination or specific to source IP address, specific to destination address or anywhere. So you can just filter it off. Okay. And one more hint I want to give you here. For example, if you are unable to type the filter, there is one more way to represent the filter. For example, I want to display IP.source node, means source address with this number. You think just you click on any of the packet like on the IP address like 192.168.56.102. I want to filter all the source packets with this IP address. Imagine, then just right click on it, and here you can see apply as filter. Then you can type test selected. Then automatically that filter will be displayed on the filter bar. Okay. And also you can do multiple here. For example, after this, I want to display again the destination node with this IP address. Then just right click on it, apply as filter. Either you can go for selected, unselected. If you type unselected, see what happens. It will just add that and along with the select next IP address with the existing IP address. So what does it mean? The source IP address, the node should contain all the sources with this IP address, and also the destination node should contain this address. Means the conversation should be between this IP address and this IP address. Just click enter, then you can see the source node will be having this IP address and destination node will be having this address. So even you can just use the right click, apply as filter, and then go for only selected, not selected. So the more explanation about these advanced filters will be given in the next video. Okay. And one more I would like to tell here. For example, see, I will go for TCP packet, and here in the TCP, for example, flags I will go. In the flags, I want to display all the TCP packets where the flag is set to, SYN flag is set to 1. All the TCP packets where the SYN flag, already we know in a TCP header we have 7 flags, that is reserved, sorry, urgent, acknowledgement, push, reset, SYN, FIN, SYNAC, all those. So I want to display all the TCP packets that are having the flag set to 1. So what is the command? Just you can type TCP packets dot. So the flags in that I want to go for which one? SYN, SYN, SYN bit, which is equal to 1. Either you can go for SYN bit or reset bit. Just I want to know which are all the packets that are established the connection. SYN flag will indicate that. Just click enter. Then there are 652 packets where the SYN flag is set to 1. So these are all the connection established. You can see here SYN, 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 SYN like that. Okay. So if you are unable to remember that, as I already told you, just you come here, TCP, come to flags, come to right click here, and then apply as filter, and then go for selected. Automatically, that filter can be injected into the filter bar. If you are unable to remember all those, the other technique is you come here, just to right click there, sorry, left click there. You can see the, don't remove the finger on the mouse. You should just keep on keeping your finger on the mouse. So automatically that filter will be taken, and then drop it on the filter bar. That is also possible. So if you want to display all the TCP packets that are where the acknowledgement is set, so here this is the acknowledgement field. Just click on the mouse, left click. Automatically the filter will be taken into the account, and then drop it onto the filter bar. So tcp.flags.acknowledgement double equal to 1. So in this way, you can just practice all the filters as per your requirement, and you can go for filtering the traffic. So in the upcoming video, I will be showing still some more advanced filters that are more helpful in encryption and also authentication techniques. Okay, so you just practice all these filters which I have shown now. Okay. Thanks for watching and subscribe for more videos. Bye.